So in this series, we're going to continue working on computing with exponents. This time, we're going to be looking at a specific rule that deals with quotient. And we need to remember that quotient means to divide. I am dividing powers. So here's the rule. If I see division and I have the same base, I'm going to keep the base and subtract the exponents. Keep the base, subtract the exponents. So a way to remember this, they're like, okay, multiply to get bigger, add to get bigger. Quotient, dividing gets smaller, and subtraction gets smaller. So that's a way that you can remember the two things together. So again, we have to make sure we see division, which means we're going to see a fraction bar, and we're going to have the same base. We have to have both things to be true. All right, so let's look at what that actually means. So I'm going to write this out. So we have 3 to the 7th power being divided by 3 to the 5th power. All right, so what does this actually mean? Well, this means I get a better pen that actually is going to write. All right, we're going to say this would be 3 times 3 times 3 times 3 times 3. That's 5 of them. 3 times 3. So 7 3's being multiplied together. And that's being divided by 5 different 3's that are multiplied together. Well, any number divided by itself makes the number 1. So 3 divided by 3 is 1, and 3 divided by 3 is 1, and then this 3, and 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 this 3. But look, there's still 2 3's left. So in this case, it's kind of like that battle. Who's going to win, the top or the bottom? The top is going to win, and how many is he going to win by? He's going to win by 2. Notice 7 minus 5 makes 2. So that's why this rule works. So there's 2 ways to look at this. You can say the going to war, the who's going to win, who's bigger, how many, and that's where he's going to live. Or you just subtract the exponents, and it's going to work either way. All right, so just like all the other videos, as you do this, if you want to try it yourself, I'm going to pause after reading the equation out loud. Give it a try and see if you match me. All right, so this first one, we have k to the 7th being divided by k to the 3rd. So knowing this information, what are we going to get? Well, we start off and we see it's division, which means we're going to subtract. So we keep our base and we subtract our exponents, and we need to subtract them in the order that it's given to me, which means I am going to have 4 k's left. 7's going to win, and he's going to win by 4. Let's try another one. All right, so this time we added a coefficient similar to multiplying our product. We still have to use and deal with these coefficients. So again, if you want to pause and try, we have 6m to the 3rd being divided by 2m. So the way we treat this is we want to treat them as their own separate entities. So we have 6 divided by 2, and we're going to actually solve that. 6 divided by 2 makes 3. M cubed and m, right? Remember our rules. Who's going to win? Well, that top's going to win, and how many is he going to win by? He's going to win by 2. Or you could subtract 3 minus 1. So we need to remember that m does represent 1. Time to get a little bit harder. We have 10a squared b cubed divided by 5b. Ooh. All right, so again, we want to treat these as separate entities. We're going to have 10 divided by 5, which would get me 2. Now, when I go to circle these a squareds, notice there's nobody in the denominator to pair with. He is on his own, and he stays put. He's like, ooh, I'm safe. Nobody's subtracting from me. I am good. So you don't want to combine them with a letter that isn't his. Remember the rule. The bases must be the same. Which means here I might have to draw diagonally, and that's okay. But here I have b to the 3rd divided by b. Well, when I subtract that, or when I decide who's going to win, well, this top b is going to win, and he's going to win by 2. All right, one more. You can do it. All right, we have 2 to the 5th times 3 to the 5th times 5 squared divided by 2 cubed times 3 to the 4th times 5. So again, we need to focus in on the bases. And those that are alike, those are the ones that we can apply the rule to. All right, so we have 2 as our base. And the top's going to win by 2. We have 5, or I'm sorry, we have 3, I can read. And the top's going to win by 1. And then we have our bottom, which means our 5 is going to win. Now I'm going to actually put one more, and I'm going to mirror it next to this one because I want you to see the difference. So if I have 2 to the 5th, 3 to the 5th, and 5 squared, I'm going to still keep that top the same. But I'm going to change my bottom, and I'm going to say 2 to the 3rd times 3 to the 4th, but I'm going to say 5 to the 5th on that bottom. Okay? I want you to see the difference. Okay? I'm still going to get, in this first one, my 2 to the 2nd, because the top's going to win. And I'm still going to get my 3 to the 1st. But notice my denominator one. Who's going to win? Isn't that bottom? And how many is he going to win by? He's going to win by 3. And he stays in the bottom because that's where he's winning. But notice what happens if I were to subtract. I would get 2 squared and I'd get 3. But notice 2 minus 5, well, that makes -3. I want you to keep this in your back of your mind because the 5th rule that we're going to look at with negative exponents, notice what happens. When he was negative with the subtraction, he actually lived in the denominator. Right? So hopefully all of this made some sense and you're able to try it yourself and be successful with it. More videos are going to be happening with our laws of exponent rules.